methodologies will be presented by Stefano Ferrari.
Vediamo.
Good afternoon. Let's try and see how we treated the data in order to obtain information which could be easy to interpret and easy to implement and apply.
Queste sono cose che sono già state riepilogate. Una cosa importante da ricordare.
All this has already been said. Please let me repeat that this project is in progress. It is going to be concluded in approximately 1 year from now. By then, we count on having all the elements that will make it possible for us to confirm and validate the observations and conclusions that, for the time being, are not final. The guideline of the entire project is identifying an index, a test, something which makes it possible to predict the propensity of white to resist and age. Of course, they do change. Enologists wouldn't want wines to change, at least until they are consumed. But so we set up tests to understand more about the aging potential of wine, and we focused specifically on temperature and the time duration of tests. Here, let me go back to the Arrhenius thermal constant, which we apply in order to ascertain how wines react to temperature. Of course, it is not so that we aim at testing cases which respond to a little extent or that do not respond at all, because that wouldn't be relevant, nor can we monitor reactions that are highly sensitive to temperature, because we wouldn't have data which are good enough to validate. We kept the wines for 90 days at cellar temperature. Possibly we should make reference to 1 year data. But of course, tests should not be too long either, in order to overestimate the effect of temperature vis-à-vis the natural aging of the wine. We selected all the parameters that you saw in Francesca's contribution. Thank you, Francesca, by the way, for replacing Dr. Bellincontro perfectly. We selected a series of variables that are significant in explaining the differential and incremental differences of the components of wine. And this includes 5 samples of white and also the tests where probability is 95%. You see that the most significant ones are variables related to chromatic color features and the composition in polyphenols, and also additional compounds which are more linked to the metabolism of a number of amino acids, which translate into mass and HPLC and other things. You have, in addition to that, a large group of aromatic substances that for whites were highly indicative. Let's now consider a series of parameters individually, so that we understand how they behave in the test conditions and what they can tell us about the aging of wine. I would like to state once again one important element, which is that we have to validate this data over a longer time period. Here you see a number of compounds which prove to be sensitive to an increase in temperature. And we see the dynamics of the creation of prontocyanidin biphosphonate at 35 degrees for 5, 10 to 15 days, and 45 degrees after 1, 5, and 10 days. That has been compared and contrasted with the control, 13 degrees, 90 days. This is expressed in terms of difference vis-à-vis T0. So there is a good correlation, time zero. There is a good correlation between what you have in the tests and what you observe in the wine stored at low temperature. That goes for both temperatures, 35 and 45 degrees, and already in a shorter time period. So evidently there is a strong influence on the part of temperature. Here we compare and contrast the two of the CLab color parameters. Blue, green fraction, L, which is light, and or brightness, sorry, and this is compared and contrasted with the control sample, the initial sample. Here you have samples subjected to 45 degrees temperature for 1 day, and then you have the sample 13 degrees, 90 days. You see that there are incredible similarities between the two conditions. TDN, norisoprenoid, relates to increases in temperature, is influenced by increases in temperature. There is a good correlation also in this case with what happens in the control wine. And this happens already in shorter time periods, even more so than in longer time periods where we possibly estimate the effect of temperature. Then there are additional aromatic terpenic compounds which provide and show good correlations, even though we have trends that could be less homogeneous than is the case with other compounds, because they have a more complex situation due to the release of aromas by the precursors that compete with possible degradation and decay phenomena. Obviously, this also pertains to compounds which could turn out to be too much cultivar dependent. In the tested samples, there are good correlations. Linalool proves to be less influenced by temperature, in that differences are closer to what happens in the control sample, and the terpenol is more sensitive to temperature. Phenyl ethyl acetate, which is a fermentation ester, yet another important aromatic compound, is what you see there. Also in this case, we observe complex phenomena with possible parasitic or competing reactions. In any case, also here, we find a very good correlation between what happens in the samples, in the tests, and in the control sample. Here, time periods are a bit longer, and temperatures are a bit lower, so it is less sensitive to temperatures. Here we have amino acid metabolites. Here we find no direct correlation when considering both the tested samples and the control one. So it is so that we can identify models for behavior between content and temperature, but it is only 5 samples. These tests proved to be valid also during the calibration phase, and yet we must be careful because it is only 5 samples. After identifying the variables that actually correlate with what happens in wine, vis-à-vis wine stored at low temperature, we asked ourselves how we could simplify as much as possible the interpretation of data. We wanted to find, in other words, an index that would express all this. Here we have a 3D PCA, and the characterization of the samples is what you see. This is the initial condition, 13 degrees, and after 10 days, which was the beginning, basically, at 10 days. And then after 90 days. And that was in function of the variables that proved to be significant and which we partly saw. The graph represents the very same variables for one of the samples, Sauvignon SB, as you see there, Sauvignon Blanc, which gives the difference divided by standard deviation and to the square. So you see here a profile of the sample for each point and each variable considered after being normalized. If you add all the indexes, you get simplified indicative values for each sample. If we do the very same of processing on the samples at the 45 degrees 1 day, 35 degrees 5 days, or 90, we see that the difference here, in the case of 45 degrees 1 day, is close, or rather correlates well with an index of 0.8 with the index found in the samples which acted as a control, 13 degrees 90 days. This is the very same graph we saw earlier on. Blue is the same line that we saw earlier on for the Sauvignon Blanc sample 1390. This has been compared and contrasted with the profile in the other 2 conditions of the test. So we will further monitor the situation, make an analysis and validate, but we could say that this could be a guiding element in assessing all of those tests that will be considered throughout the project and during the rest of the project. Then for sure, when concluding this project, we will be able to introduce new corrective elements. Thank you, and thank you to Dr. Arapitzas and the Foundation at Mugmach staff for their scientific support. I would like to thank Dr. Riccardo Croce at ISVEA. Thank you for supporting us in analyzing data, and thanks to you all for your attention.